Nuclear power plant. A nuclear power plant is a thermal power station in which the heat source is a nuclear reactor. As is typical of thermal power stations, heat is used to generate steam that drives a steam turbine connected to a generator that produces electricity. Aside from the source of heat, nuclear power plants are very similar to coal-fired power plants. However, they require different safety measures. These power plants operate in 32 countries and generates about a tenth of the world's electricity. Most of the Europe, North America, East Asia, and the Southeast Asia. The United States is the largest producer of nuclear power, while France has the largest share of electricity generated by nuclear power at about 70%. Nuclear power reactors use heat produced during atomic fission to boil power and produce pressured steam. The steam is routed through the reactor steam system to spin large turbines, blades that drives magnetic generators produce electricity. Like any industry, the nuclear industry generates waste. However, unlike many industries, nuclear power generates very little of it and fully contains manages what it does produce. The vast majority of the waste from nuclear power plant is not very radioactive and for many decades had been responsibly managed and disposed of. If nuclear power has used to supply a person's electricity needs for an entire year, only about 5 grams of highly radioactive waste would be produced, which is the same weight as a sheet of paper. The used fuel comes out of the reactors can be managed in different ways, including recycling of energy productions or then direct disposal. As a matter of fact, nuclear power plants are highly complex energy generation system comprised of numerous interplaying subsystems and interacting components. A number of different materials can be used to fuel reactor, but most commonly uranium is used. Uranium is abundant and can be found in many places around the world, including the oceans. Other fuels such as plutonium and thorium can be used. Most of today's reactions contain several hundred fuel assembles, each having thousands of small pellets of uranium fuel. A single pellet contains such as energy as there is any industry. The nuclear industry generates waste. However, unlike many industries, nuclear power generates very little of it and fully contains and manages that it does produce. The vast majority of the waste from nuclear power plants is at very radioactive and for many decades has been responsibly managed and disposed of. If nuclear power was used to supply a person's electricity needs for an entire year, only about 5 grams of highly radioactive waste would be produced, which is the same weight as a sheet of paper. The used fuel comes out of the reactors can be managed in different ways, including recycling for energy productions or direct disposal. A matter of fact, many countries have been using recycled fuel for decades to partially fuel the reactors. Ocean thermal energy conversion or OTEC is a process that can produce electricity by using the temperature difference between deep cold ocean water and warm tropical surface water. OTEC is an energy technology that converts solar radiation to electric power. OTEC utilizes the world's largest solar radiation collector. The ocean contains enough energy power of all the world's electric needs. Oceans cover more than 70% of Earth's surface, making them the world's largest solar collectors. OTEX is a renewable energy technology that converts solar radiations into electric power by use of Earth's oceans. OTEC process uses temperatures, a difference between cold deep water 5 degrees Celsius and warm surface water 27 degrees Celsius to power a turbine to generate electricity. This plant works on the principle of a closed Rankine cycle. Warm water is used as to evaporate working fluid like ammonia or hydrocarbon refrigerant. Evaporated fluids expands in a low pressure turbine, which is coupled with a turbo alternator, produce electricity. Closed cycle OTEC system, warm water evaporates a working fluid, such as ammonia, flowing through the heat exchanger. The vapor expands at moderate pressures and turns the turbine coupled to a generator that produces electricity. The vapor is then condensed in heat exchanger or the condenser using cold seawater pumped from the ocean deeps through a cold pipe. The condensed working fluid is pumped back to evaporator to repeat the cycle. The working fluid remains in a closed system and circulates continuously. The heat exchangers, evaporator, and condenser are large and crucial components of a closed cycle power plant, both in terms of actual size and capital costs. In an open cycle OTEC, the water sea itself is used to generate heat without any kinds of intermediate fluid. Open cycle OTEC uses the tropical ocean's warm surface water to make electricity. The open cycle consists of the following steps: flash evaporations of fractions of the warm seawater by productions of measure below saturations value corresponding to its temperature, expansions of vapor through a turbine to generate power, heat transfer to the cold seawater thermal sink resulting in condensation of the water working fluid. Compression of the non-condensable gases, air released from the seawater streams at a low operating pressure. The pressure required to discharge them from the system.